Using Romex for temporary wiring, especially in outdoor environments, is generally not recommended due to several safety and code compliance concerns. Romex, also known as non-metallic sheathed cable, is primarily designed for indoor, dry locations within permanent structures. Its construction and insulation are not suitable for the harsh conditions often encountered in temporary setups such as outdoor bars, stages, or shops. Firstly, Romex is not designed for outdoor use. The outer jacket of Romex is not resistant to ultraviolet, UV, radiation from the sun, moisture, or physical abrasion. Prolonged exposure to sunlight can cause the jacket to degrade, leading to cracking and eventual failure of the insulation on the conductors inside. Secondly, moisture is a significant concern. Romex is not waterproof or even water resistant. If water penetrates the jacket, it can lead to corrosion of the conductors and create electrical hazards, including short circuits and ground faults. In outdoor settings, exposure to rain, humidity, and condensation is almost inevitable, making Romex an unsuitable choice. Thirdly, physical damage is another factor. Romex is relatively fragile compared to other types of wiring. It can be easily damaged by foot traffic, equipment, or accidental impact. Damage to the outer jacket or insulation can expose the conductors, creating a risk of electric shock or fire. Fourthly, using Romex in temporary outdoor setups often violates electrical codes. The National Electrical Code, NEC, specifies approved wiring methods for different applications and environments. Temporary wiring installations have specific requirements, and Romex typically does not meet these requirements for outdoor or wet locations. Fifthly, the lack of grounding protection is another issue. While Romex includes a grounding conductor, the overall protection against ground faults is limited compared to using ground fault circuit interrupters, GFCIs, in conjunction with appropriate wiring methods. Sixthly, the potential for improper installation is higher with Romex in temporary settings. Because temporary setups are often assembled and disassembled quickly, there is a greater risk of improper connections, inadequate support, and other installation errors. These errors can compromise the safety of the installation and increase the risk of electrical hazards. Seventhly, the presence of rodents or pests can pose a threat. Outdoor environments are more likely to have rodents or pests that can chew on the Romex cable, further compromising the integrity of the wiring. Eighthly, the risk of electrical shock is significantly increased when using Romex in damp or wet locations. Water can act as a conductor, making it easier for electricity to flow through a person's body if they come into contact with damaged or exposed wiring. Ninthly, the potential for fire hazards is another critical concern. Damaged or improperly installed Romex can create short circuits or ground faults, which can generate heat and ignite nearby combustible materials. Tenthly, the cost savings of using Romex are not worth the risk. While Romex may be cheaper than other types of wiring, the potential consequences of electrical hazards, including injury, property damage, and legal liability, far outweigh any cost savings. 11thly, the alternative wiring methods provide superior protection. Options such as portable cords, cables suitable for outdoor use, and ground fault circuit interrupters, GFCIs, offer a much higher level of safety and reliability. 12thly, consider using portable cords and cables that are specifically designed for temporary use. These cords are typically more durable and resistant to moisture, abrasion, and UV, ultraviolet radiation. Types like SU or similar ratings are suitable for outdoor applications. 13thly, ground fault circuit interrupters, GFCIs, are essential for temporary wiring installations. GFCIs protect against electrical shocks by monitoring the current flow in a circuit and quickly tripping the circuit if a ground fault is detected. 14thly, ensure that all temporary wiring is properly supported and protected from physical damage. Use appropriate clamps, connectors, and enclosures to secure the wiring and prevent it from being damaged by foot traffic, equipment, or other hazards. 15thly, regularly inspect the temporary wiring for any signs of damage or wear. Replace any damaged or worn wiring immediately to prevent electrical hazards. 16thly, Overcurrent protection devices, OCPDs, such as circuit breakers or fuses, are necessary to protect against overloads and short circuits. Ensure that the OCPDs are properly sized for the temporary wiring and the connected loads. 17thly, consult the National Electrical Code (NEC) and local electrical codes for specific requirements for temporary wiring installations. These codes provide detailed guidelines on approved wiring methods, grounding, overcurrent protection, and other safety measures. 18thly, consider using a qualified electrician to install and inspect temporary wiring. A qualified electrician has the knowledge and experience to ensure that the wiring is installed safely and in accordance with all applicable codes. 19thly, proper grounding is crucial for temporary wiring installations. Ensure that all metal parts of the electrical system are properly grounded to provide a path for fault current to flow back to the source, reducing the risk of electric shock. 20thly, avoid overloading circuits. Overloading can cause the wiring to overheat, which can lead to installation damage, short circuits, and fire hazards. 21stly, use weatherproof enclosures for all electrical connections and equipment in outdoor locations. Weatherproof enclosures protect against moisture, dust, and other environmental factors that can damage electrical components. 22ndly, label all temporary wiring and equipment clearly. Labeling helps to identify the purpose of the wiring and equipment and can prevent accidental disconnection or damage. 23rdly, train personnel on the safe use of temporary wiring and equipment. Training can help to prevent accidents and ensure that the wiring is properly maintained. 24thly, use cable trays or raceways to support and protect temporary wiring runs. Cable trays and raceways provide a safe and organized way to route wiring and prevent it from being damaged or becoming a tripping hazard. 25thly, avoid running temporary wiring across walkways or areas where it could be damaged by foot traffic or equipment. If it is necessary to run wiring across walkways, use cable ramps or other protective measures to prevent damage. 26thly, use only approved electrical equipment and materials. Avoid using substandard or unapproved equipment, as it may not meet safety standards and could create electrical hazards. 27thly, regularly test ground fault circuit interrupters, GFCIs, to ensure that they are functioning properly. GFCIs should be tested monthly to verify that they are able to trip the circuit in the event of a ground fault. 28thly, use only qualified personnel to perform electrical repairs. Electrical repairs should only be performed by qualified electricians or other trained personnel. 29thly, disconnect the power before working on any electrical equipment. Always disconnect the power at the circuit breaker or fuse box before working on any electrical equipment to prevent electric shock. 30thly, use appropriate personal protective equipment (PPE) when working with electricity. Personal protective equipment (PPE) such as gloves, safety glasses, and insulated tools can help to protect against electric shock and other electrical hazards. 31stly, be aware of the potential for arc flash hazards. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit or other electrical fault. Use appropriate arc flash protection when working on or near energized electrical equipment. 32ndly, follow lockout tagout (LOTO) procedures when working on electrical equipment. Lockout tagout (LOTO) procedures help to prevent accidental energization of equipment during maintenance or repair. 33rdly, use insulated tools when working on or near energized electrical equipment. Insulated tools provide a barrier between the user and the electrical current, reducing the risk of electric shock. 34thly, be aware of the location of overhead power lines. Overhead power lines can pose a serious electrocution hazard. Maintain a safe distance from overhead power lines when working with ladders, scaffolding, or other equipment. 35thly, be aware of the presence of underground utilities. Before digging, call your local utility companies to locate any underground utilities in the area. Damaging underground utilities can create electrical hazards and disrupt service. 36thly, use ground fault circuit interrupter (GFCI) protected extension cords in damp or wet locations. Ground fault circuit interrupter (GFCI) protected extension cords provide additional protection against electric shock in damp or wet locations. 37thly, avoid using extension cords as a permanent wiring solution. Extension cords are intended for temporary use only. Using extension cords as a permanent wiring solution can overload circuits and create fire hazards. 38thly, choose the right size extension cord for the load. Using an undersized extension cord can cause it to overheat and create a fire hazard. 39thly, inspect extension cords for damage before each use. Replace any damaged extension cords immediately to prevent electrical hazards. 40thly, avoid running extension cords under rugs or carpets. Running extension cords under rugs or carpets can trap heat and create a fire hazard. 41stly, do not overload extension cords. Overloading extension cords can cause them to overheat and create a fire hazard. 42ndly, unplug extension cords when not in use. Unplugging extension cords when not in use can save energy and reduce the risk of electrical hazards. 43rdly, use a surge protector to protect sensitive electronic equipment. A surge protector can help to protect electronic equipment from damage caused by power surges. 44thly, be aware of the symptoms of electrical shock. The symptoms of electrical shock can range from mild tingling to severe burns and cardiac arrest. Seek medical attention immediately if you experience any symptoms of electrical shock. 45thly, know how to respond to an electrical emergency. In the event of an electrical emergency, disconnect the power, call for help, and provide first aid to the injured person. 46thly, educate yourself about electrical safety. Learning about electrical safety can help you to prevent accidents and protect yourself from electrical hazards. 47thly, follow all electrical safety rules and regulations. Electrical safety rules and regulations are designed to protect people from electrical hazards. Following these rules and regulations can help you to stay safe.